Brian Hummel here, standing in a parking lot that could be just about anywhere USA. Pretty traditional parking lot, all the way down to the drainage feature. So this is where the water from the parking lot goes into the storm drain. And that's where this changes. We're here in Tallahassee, Florida, and these people have been doing green infrastructure for a long time. This system, I believe, was built in 1987. All the parking lot runoff flows into this little retaining pond. Water settles out. It infiltrates down into the soil as free gravity powered irrigation to things like that cypress tree. And when it gets full enough, it'll flow down this probably 14, maybe 16-inch diameter pipe. They have it covered up, and you can see that there's some debris on top of it. So water did, in the large storm we had earlier today, overtop that, flow down. Then the water, and if there's too much water, it can go over this spillway that they reinforced and cross this sidewalk. But then this entire basin here can hold a tremendous amount of water, well, relatively speaking, because it can pond up maybe 100 feet long, 30, 40 feet wide, and on average, maybe 3.5, 4 feet deep. And all this water soaks in to feed the cypress trees as well. So this is a way to take a stormwater liability and turn it into a free gravity irrigation asset. So I thought this thing would just fill up until it started going, you know, down this large, probably 30-inch diameter pipe. But I heard a noise when I came up to it, and I'll see if I can't get down there. There's a little trickle of water coming from, and it's warm, little trickle of water coming from this pond. There is a square in the bottom of that pond that drains into here. So instead of the water coming off this parking lot and say, I don't know, 100 gallons a minute, it gets caught in here. The level of this pond will raise. You can actually see the height of how high the water got. It got to about that high because that's where the sediment drops out. And but then when it leaves, it only leaves in a trickle until it catches enough storm water to fill the entire basin. Ooh, let me get over here. Until it catches enough storm water to fill the entire basin. So it starts filling up, starts filling up, starts filling up, starts filling up. And then when it gets to here, it will start overflowing and going into that pipe and going down. And then you'll have, you know, if it's really full, you might have as much as a 3 foot, you know, 2.5, 3 foot diameter wall of water going to the local river. But that's still dramatically mitigated from what would happen if there was none of this green infrastructure and all the water from these acres and acres of asphalt just went rushing down to a concrete ditch, flowing into another concrete ditch, flowing into another concrete ditch, flowing into the river, and flooding out the towns downstream. So thanks for watching about this green infrastructure video, and I want to end showing you the date. Again, 8/20/1987, meaning these guys in Florida, some of these engineers, they know how to deal with water. They've been doing it a long time, and I wish there was more of this type of work around the entire country. Thanks for watching, guys.